Hey everybody, welcome back. Mr. Smith here. Welcome to our asynchronous return. I hope all of you guys had a great time with your families. You all got a chance to rest and relax and have some fun together. However you celebrated them, I hope you had a lot of fun with it. I'm going to give you three things in this short video. The first thing is that I'm going to take you through all the skills you need to kick butt on this little activity and get a 10 out of 10 on it. It's a little mini lab. The second thing I'm going to give you is an insight into a couple of the concepts we're going to get into when we talk about force, which is just around the corner in our year in physics. And the third thing is, for those guys that want to, I'm going to give you a little review of the skills of velocity graphing that you should have from graphical analysis. And what I'm going to tie that into is, if you want to, I'm going to give you a chance to go back and redo the Tower of Terror lab that gave a number of guys some trouble and resubmit it for full credit. So if you want to go backwards and fix that one, it was worth 20 points. I'm going to give you a chance to do that, and I'll walk you through the skills that are going to help you in the Baumgartner lab that we're going to talk about, but also the Tower of Terror lab. Okay, so first thing, let's go dive on this one. So speaking of diving, this is all about a guy leaping out of a hot air balloon that's really high in space. So what I've drawn here is a guy with one arrow pulling down on him that represents force of gravity. Force of gravity? It's how hard planet Earth pulls down on you. You read this number whenever you step on a bathroom scale. And you know from growing up that when you were a little kid, you didn't weigh very much. That's because you didn't have very much mass. So the more mass we have, the more planet Earth pulls down on us, the more force of gravity we have. Pause the video deck if you want to, but what free fall is the situation when gravity is the only force acting on you. So what we want to do in this lab is check out, was Baumgartner in free fall for a whole 1 minute, or wasn't he? Second concept that you're going to get into when you talk about skydiving is a thing called terminal velocity. Again, pause the deck if you want to and write this down. Terminal velocity happens when you can't go any faster. So for most people, if you spread eagle, your terminal velocity will mean that the force of air resistance pushing up on you is equal to whatever you weigh. So for most of us, it's between 100 and 130 miles an hour. So it's fast. With a parachute, same idea. Force up equals force down means you can't go any faster. It's a lot lower. And that's why we use parachutes, right? So to the lab itself, what we're going to do is study this guy in the lab. This is Felix Baumgartner. But I wanted to give a nod to this guy right here. Every time you've gone on our website, you've seen this image. This is Joe Kittinger, who in the late 1950s, early 1960s, did 3 jumps from space before anybody knew it was safe. He's got a pressure suit on. He's going to jump out of a hot air balloon that you can basically see here in the background. And he falls from over 100,000 feet 3 times. That's about 23 miles high. Why? The Air Force knew that the pilot safety systems, their parachutes and their ejection seats and all that, weren't up to par with the airplanes that were flying higher and higher and higher and pushing into the edge of space. Felix Baumgartner did it again in 2012, really just to break records and do a cool publicity stunt for Red Bull. Watch the whole video, though, if you want to, and you'll see, I think, why Felix Baumgartner himself said, I would never do this stunt again. So what's the lab activity about? You're going to zero in on the Red Bull display in the video that I gave you. And what you're going to notice right here is that I've stopped the timer as close to 0 seconds as I can. You want to start your lab there. You notice I wasn't perfect? That's fine. You're not going to be able to be perfect either. I don't think you can get exactly 0 seconds. Then you're going to want to get focused on this right here. That's his altitude in meters. And over here is his airspeed in kilometers per hour. Okay? And what you're going to do is take data about every 5 seconds. So every 5 seconds, you're going to write down his altitude and airspeed and make a little data table out of it. And the thing I wanted to give you is that if you wanted to know if he was in free fall, if you're in free fall, you'll accelerate at 1g. And we know that that's 9.8 meters per second in metric system. The Red Bull people didn't give me the option of meters per second. They gave me kilometers per hour. So I wanted to give this to you for free, that 9.8 meters per second is the same thing as 35 kilometers per hour per second. So here's the story. If you make your velocity graph with this, the y-axis in kilometers per hour, and the x-axis in seconds, and you study the slope of it, if the slope of that graph equals 35 kilometers per hour per second, this dude's in free fall. Okay? That's the lab. Now, for those of you guys that want that to take a little bit of skill building, I'm going to show you some stuff. Again, you can resubmit the Tower of Terror lab if you want to, but I'm going to pause it right there. I'm going to jump onto my iPad and take you through those skills right now. Okay, so from the beginning, what you should have handy is all of the position data in the Tower of Terror. That's a lot of data points. That's why this lab is worth so many points. So all of these numbers here that I'm showing you, at this point, you could just copy my data table and use it. This is really about the skills, and I really want you to make sure that you know how to work these. What I've got is a position graph. So the first thing that we worked on to get this into a velocity graph was how do you create velocity. So I'm going to tap this 3 dots next to position, and I get add a calculated column. And what I'm going to do is I'm going to create velocity out of that, and I'm going to put this velocity in units of meters per second because my positions were in meters. And I'm going to insert an expression. The expression, you should know by now, is first derivative of the position, and bango, I get a whole column now full of velocities that the car in the Tower of Terror lab had. So what I'm going to do now that I've got that is tap this left-hand button over here that says position. And I've got the option now of killing off position and creating a graph of velocity, and that's what I'm going to want to do. So I just tap any other place on the graph, and the graph has changed shapes, and now it means something totally different. So there's 2 parts to this. The very first part is that you need to know what these different sections of the graph mean. So from here, I'm dragging a blue, I just tapped with my finger and dragged from the left-hand side over to the middle that you can see. All of those points that are trending upward are the car full of people in the Tower of Terror moving in the positive direction. How do I know they're in the positive direction? Because they're above the 0 velocity. That's how I can tell. The second half of the trial, I'm going to grab in the middle and drag to the, not the end, drag right about to there. And you should know why this is true. This is also moving in the plus direction. Why? Because these dots are above the 0 of velocity. So one set of mistakes that gets made in this graph is that some folks still look at it like it's a position graph. No, no, no. If the velocity is above 0, you're moving in the plus direction. So then finally I had a third section that starts not there. I'm going to drag it one more point to the right, and I've tapped out a blue section now where you can see all the velocities are minus. This is where the ride is bounced, and it's actually heading back up because you can see the velocities are in different direction than they are when they're above 0. Okay, so thing that was key about the position graph and the way this lab was laid out was you should have imagined a motion detector at the top of the ride so that when the people fell and the position got bigger, down was equal to the positive direction. Okay? Final skill I want to give you, and this is an important one. I'm going to tap on the X and get rid of that line. We do a lot with straight lines in velocity graphs. So here's the thing. There are 3 at least, I think there's 4 different motions going on here. We're moving in the plus direction and speeding up. We're moving in the plus direction and slowing down. And we're also bouncing and moving in the opposite direction. It's garbage. It's nonsense to draw a straight line through all of that. So what I'm going to do is show you how to key in and answer a couple questions on the Tower of Terror better than many guys did. So what I'm going to do is drag this right-hand line. So you saw me, I just reached down and I tapped the right-hand line with my index finger, and I start dragging it to the left. And you can see that the slope line changes because the range of the data I'm taking keeps on changing. And what I just did was I grabbed the first 1.2 seconds worth of data. And why did I do that? Because to my eye, it looked like the graph of velocity was steeper during the first 1 second. Let me show you what I mean. I'm going to grab that line again and slide it again. And you see the line get even steeper? So what you should notice is that I've got 1, 2, 3, 4, 5, looks like about 6 data points that really form a nice straight line. That's the first 1 second of data. And look at the acceleration there, 9.3 meters per second per second. So that says to me, yeah, they drop people and they free fall for about the first 1 second on this Tower of Terror lab. Then what happens is I'm going to drag out farther and you're going to see me change something. What I see is I'm going to drag now, grab at the left-hand side and exclude that first 1 second worth of info. And now you can see what I'm doing is I'm running through another set of points that are more or less straight. You could fight over it and make it so it's more perfect, but that's not the point. What you're getting here is that you're still speeding up after the first 1 second, just not as much. So what they do in the Tower of Terror type rides is they drop you, free fall, and then they start to hit the brakes almost right away. So that you're still speeding up, but not at free fall. Why? Because if you get too much speed, the ride has to be taller for them to control you. Or they can risk hurting you at the bottom when they have to stop you suddenly, and they don't want to do that. So what I've got here, 2 sections where you're speeding up. One that's really free fall and one that's not quite free fall. Then what have I got going on? I'm going to drag this out till the point just before the line or the data dives under 0. And I'm going to drag the left-hand line and I'm going to scope out these data points. What this represents right here, you're still moving in the plus direction, but can you see the points falling down towards 0? They're all positive velocities. They are all above 0, but they're trending towards 0. So what's going on here? They're hitting the brakes on you. And if you notice, they're hitting the brakes. The acceleration when they hit the brakes is around minus 8.5 meters per second per second. So you feel this also. It's pretty close to free fall, even though you're not at all. They're stopping you right here. And then finally, if you drag this thing all the way at the end and drag the left-hand one so I can zero in on that part where he's going under 0, then you can see that actually it's during the bounce that you get an acceleration of around minus 10 meters per second per second. What I've shown you is how to move and select different parts of a velocity graph and understand the slope of them, okay? So I hope that's helpful. I've given you a lot that you can reuse if you want to redo that Tower of Terror lab. At any rate, I'll check in with you and make sure your skills are good. Bring your questions to class. I look forward to seeing you soon in real life, and take care. Bye-bye.